Welcome to the session 3 of module 1. In this session, we are studying about Karnaugh Map. In this session, we are discussing about Karnaugh Map rules, how to write a 3-variable key map, implicants, prime implicants and essential prime implicants, multiple choice questions and assignment. There are two ways to write a Boolean expression. One is sum of product expression and the other one is product of sum expression. If your expression is canonical, then we require more number of hardware. So, in order to reduce the hardware requirement, we are going for simplification of Boolean expression. The one method that we have studied is algebraic method of simplification. In the algebraic method of simplification, we were using Boolean law or Boolean theorems or Boolean algebra in order to reduce expression. But this algebraic method of simplification is lengthy process and error prone. And we may not have any guarantee that the reduced expression is minimal. So we are going for an alternate approach and better approach, which is called a Karnaugh Map method. In this Karnaugh Map method, we are writing a rectangular diagram with 2 power n number of cells, where n represents the number of variables in the function. If the function is having one variable, then 2 cells we are having in the key map. If the function is having 2 variables, then we are having 4 cells. If your function is having 3 variables, then we'll be having 8 cells, like that. Karnaugh map is the better approach in order to reduce a Boolean expression. What is Karnaugh map? Karnaugh map for an n-variable function is a rectangular diagram which is divided into 2 power n squares, each containing a minterm of the given function. The truth table that we are having is written in the form of a rectangular diagram which is divided into 2 power n squares, where each minterm represents a square in the key map. So the key map is a graphical method for representation and minimization of functions. And if your function is n variable, there are 2 power n cells in the key map. And while grouping, adjacent 2 cells differ in only one variable, adjacent 4 cells differ in 2 variables, and adjacent 2 power m cells differ in m variables. And we have to group a maximum number of groups possible. And we have to ensure that all minterms are covered. We have to ensure that all minterms are covered in the key map. This we have to remember. Adjacent 2 cells differ in one variable, adjacent 4 cells differ in 2 variables, and adjacent 2 power m cells differ in m variables. And first thing we have to do is we have to make a larger groups possible. First we have to check for 8 number of cells. Can we group 8 minterms? Next we have to check for 4 minterms, and next we have to check for 2 minterms. First we have to check for more number of groups possible. That is larger group possible. Okay. You have to group 2 power n cells, where we have to group in the powers of 2. The powers of 2. Next, these are the ways that we can write a 2-variable key map, 3-variable key map, and 4-variable key map. And for 3-variable key map, and in general, key map will be having 2 power n number of cells, where n represents number of variables in the function. And here we have to write a MSB here, to MSB for the rows and LSB for the columns. Here we are writing MSB for the rows and LSB for the columns. Let us consider I am having 3 variables, that is A, B, C. And here MSB I have to consider is the leftmost bit as MSB, that is A, and the LSB is BC. Now, to enter the minterms in the K-map, first I have to write the binary values for each rows and columns. First, we have to know how to write this LSB and MSB for the rows and columns. And MSB I am considering for the rows, where first I am writing A as 0 for first row and 1 for the second row. And LSB, BC, that is first row, first column, it is 0, 0. Next it is 0, 1. Next 1, 1. Next 1, 0. Okay. Here, this form of representing the variables in the K-map is in the form of gray code. Is in the form of gray code, not in the form of binary. Binary will be like 0, 1, 2, 3, 4, 5, 6, 7. But here the code is 0, 1, 3, 2, 4, 5, 7, 6, which is same as that of the gray code. So, which is very important. The K-map is represented by the gray code, not the binary code. Okay. Now, how we are writing the K-map? It is same as that of the truth table that we know for 3 variable function. 3 variable function is having how many combinations? 8 combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, and 0, 1, 1. Okay, this is ABC. And for next 4 variables, we are having A as 1. And BC values, it repeats 0, 0, 0, 1, 1, 0, 1, 1. If you see this, the first row is same as that of this. Okay, the first row A is 0 and BC value is 0, 0. This represents the minterm M0, where we are writing minterm 0. Okay, and next 0, 0, 1. A is 0 and the next column is 0, 1. So minterm is 1. Next A is 0 and next it is 1, 0. So 0, 1, 0 represents 2. Next is A is 0 and 1, 1. It represents the minterm 3. It represents the minterm 3. Next, for the next row, A is equal to 1. Okay, A is equal to 1. And next, 0, 0, BC is 0, 0. So it represents 1, 0, 0 is decoded into decimal value, that is 4. 1, 0, 0 in binary value. The equivalent decimal value for 1, 0, 0 is 4. Next is 1, 0, 1, which is nothing but 5. Next is 1, 1, 0. 1, 1, 0 is 6. Next 1, 1, 1 is 7. In this way, we are writing a 3 variable K-map. This is 2 variable K-map. Okay, where for the rows we are assigning MSB and for the columns LSB. Okay, we are having 2 variables for the 2 variable function, and we are having 4 to power 2 is equal to 4 minterms in the K-map. And for the 4 variable function, we are having 2 power 4, that is equal to 16 cells in the K-map. This is the way we are entering the minterms in the K-map. Okay. Next, this is the truth table for the function 2567. We know how to write the minterms in the function, in the truth table. Okay, and here we have to simplify this expression 2567 by using the K-map. Okay, for the minterms 2, 5, 6, and 7, we are having logic high because it is in the form of sum of product expression. Okay, Next, the same truth table is arranged in the form of a rectangular diagram, and we are entering the minterms in the squares. Okay, we are entering the minterms in the squares, which is a 3-variable function. The rectangular diagram is divided into how many squares? 8 squares. And here a value is 0 and here 1. These are B bar C bar, that is 0 0, B bar C 0 1, BC 1 1, BC bar 1 0. The same truth table is represented in the form of a K-map, okay, which is represented in the form of graphical method, where we are dividing the rectangle into 2 power n number of squares, and we are writing the minterms in this form, okay, in such a way that the two adjacent cells differ in only one variable, because we have to eliminate. Let us consider a bar plus a is equal to 1. Okay, a bar plus a is equal to 1, where we are removing this, removing the redundant variables of this form. Okay, so when you consider this two minterm 0 and 1, which is varying with only one variable c. When we consider 1 3, which is varying with variable b. When we consider 2 3, which is varying with variable c, like this. Okay, and when you consider when you are grouping both the rows, the minterms which are there in both the rows, then we can eliminate the variable a, like this. Okay, because a is varying from 0 to 1, so we can eliminate a. If the minterms in both the rows are high, we can eliminate variable a. Like that we have to group. And now, what are the expression? What is the function that we are having here? 2 5 6 7. For the minterms 2 5 and then 6 7, we are having logic high. Okay, now after writing the K-map, entering the minterms and entering the logic high for the respective minterms, we have to group. First, we have to check for an octet, 8 number of cells, whether they are logical high or not. If no 8 cells are adjacent which are logic high, then we can go for quad. Okay, quad. Next, if no 4 cells are adjacent, next we have to go for pair. That is 2 cells we have to group. Okay. Next we have to go for pair. Here 2 6 are adjacent to each other and 5 7 are adjacent to each other. So we can group this 2 6. We can group this 2 and 6 minterms. And what is the reduced term that we are getting here from these two? From these two rows, we are eliminating the variable a, because a is changing from 0 to 1. And from this column, we are getting BC bar. When we group two adjacent cells, we are able to eliminate only one variable. We have eliminated variable a, and we will get two variables, that is BC bar. Okay. Next, from these two minterms 5 and 7, we are eliminating the variable b here, because b is changing from 0 to 1. So from this row, we are having term a, and from this column, from these columns, we are getting c. So what is the product term I am having? EC. When we are simplifying the SOP function, we will get a product terms, and we have to sum them up. Okay, that is AC plus BC bar. Okay, next we have to know the rules while grouping the K-map. We have to group the K-map in such a way that we have to group only the logical highs. We should not include any cell containing 0 whenever your expression is sum of product expression. Whenever your expression is Product of sum, we have to group only the logical zeros. To group or to simplify an SOP function, we have to group only the logical highs. We should not include a cell containing a 0. Second rule, groups may be horizontal or vertical but not diagonal. We have to group only horizontal or vertical but not diagonal. Okay, which is wrong because these two diagonal cells are not adjacent to each other. So we can group it horizontal or vertical cells. Groups must contain 1, 2, 4, 8 or in general 2 power n cells. We have to group in such a way that we have to group 2 power n number of cells. Okay, 2 power n number of cells. Other than this 2 power n number of cells, we should not make the grouping of 3, 5, 6, 7 cells grouping, which is wrong. If n is equal to 1, a group will contain 2 1s since 2 power 1 is equal to 2, which removes one variable. If n equal to 2, a group will contain 4 1s, which removes 2 variables. 2 power 3 is equal to 8, removes 3 variables. If you are having m variable function, then if you are grouping the cells with 2 power n, then you will be having m minus n literals in the product term. Okay, this you have to remember. Okay, if you are having a 5 variable function, let us consider, then if you are making an octet, then octet will be having how many cells? That is 8, but here 2 power 3 is equal to 8. So 5 minus 3 is equal to 2. We will be having 2 terms in the product term. Okay, we can eliminate 3 variables from this 5 variable when we are grouping 2 power 3 number of cells. Okay. Next, the fourth rule is each group should be as large as possible. We have to group in such a way that the group should be large. Okay, and then each cell containing a 1 must be in at least one group. We should not leave any minterm, which is logic high. It should be in any one of the groups. If we cannot group that single minterm, that minterm should be entered in the final expression, should be written in the final expression. Groups may overlap. If you are possible to do grouping, let us consider we have grouped 4 cells. But if you are having another one here, we can overlap this. We can overlap this minterm if you can make it as a larger group possible. Okay, the groups may overlap. Groups may wrap around the table. If you are having a 3 variable or 4 variable function, we can wrap the table, which means that this top and bottom cells, left and rightmost cells are adjacent. So if you fold this leftmost and rightmost cells, then both are adjacent, logically adjacent. So we can group those topmost and bottommost cell and leftmost and rightmost cells. This is very important, okay, while grouping. These are the 7 rules that we have to remember while grouping. And the steps to solve the expression using K-map. First step is select K-map according to the number of variables. Depending on the number of variables in the function, we have to select or write the K-map using 2 power n number of cells. Next step is identify minterms or max terms as given in problem. If the problem is SOP, then we have to enter logic highs in the minterms. If the problem is product of some expression, we have to enter logic zeros in the max terms. Next, make rectangular groups containing total terms in power of 2 and try to cover as many elements as you can in one group. Okay, we have to group a larger group possible by considering a logic highs. Okay, we have to consider first larger groups possible, 8, then go for quad, then go for pair. After grouping, okay, we will get a product term for each of those, and after getting the product terms, we have to sum them up. These are the steps that we have to follow while grouping, or while writing the K-map, or while simplifying the expression using the K-map. Next, we will consider one example. 3-variable K-map. Simplify the expression y is equal to f of a comma b comma c, that is equal to summation 1, 2, 3, 6, 7. They are giving us a sum of product expression, where we are having summation with the min terms. Whenever they represent a summation with min terms, we have to enter logic highs for these min terms, okay, in the K-map. First step is we have to write a K-map with 2 power n number of cells. Okay, after writing, notate that MSB and LSBs with the variables, and after that write the binary values for the rows and columns, and after that write the min terms, decimal notation, which is the decimal decoded value for the binary. And here we have written the min terms, decimal notation 0, 1, 2, 3, 4, 5, 6, 7. After that, we have to write the logical highs for the respective min terms, which is present in the equation. Now, for which min terms it is logic high? 1, 2, 3, 6, and 7. After entering the logic highs for the respective min terms, we have to group them. We have to check for the octet first. No 8 cells are logic high here. So next go for quad, 4 cells. Here 2, 3, 6, 7 cells are logic high. We can group it as a quad. Okay, we can make it as a quad. After grouping it as a quad, we have to write a product term. We have to consider the rows and columns of the respective min terms which are grouped. So when we consider the rows, this 2, 3 belongs to the row 0 and 7, 6 belongs to the row 1. Okay, so we are having min terms in both the rows. So we can eliminate the variable a because it is changing from 0 to 1. And when we, by considering the columns BC bar, here variable B is same, but variable C is varying. So we are eliminating this variable C from these two columns. So we are getting the product term as B. Next, which is the min term that is left over? Min term 1. Since min term 1 is adjacent to min term 3, we can group these two, min term 1 and 3. Okay, we can group min term 1 and 3. And what is a reduced expression? This min term 1 and 3 is in the row 0. Okay, and we are getting a bar from the row, and from these two columns we are eliminating the variable B and we are having the variable C. So we are getting the product term a bar C. The final expression is y is equal to f of a comma b comma c is equal to a bar C plus B. This is the way we have to write the K-map, by considering how many variables we are having in the function, and after writing the K-map, we have to enter the logical highs for the respective min terms, and we have to follow the rules for grouping, and then we have to get a final expression. Next is a very important topic, that is implicant, prime implicants, and essential prime implicants. Whenever we are considering an expression which we have to simplify, okay, the expression which is having the min terms, all the single min terms are implicants. And whenever we are considering those min terms to form a groups possible, then the permitted group of minterms are also called as implicant of an output function. Implicant of an output function is a single minterm or permitted group of minterms. Next, prime implicant. Prime implicant is a largest possible group of minterms. If you are writing the minterms in the respective, if you are writing the logical highs for the respective minterms, we have to check for the largest groups possible. Okay, when we are making the largest group possible and when we get the product term, those product terms we are calling it as a prime implicants. And one thing we have to remember is whenever we are making a larger group possible, we should not, if you are grouping 4 ones, let us consider. From this largest group possible, we should not make a smaller groups again in that larger group. This is wrong. Okay. Then these two will not be a prime implicants. The smaller groups will not be a prime implicant. So whenever you are writing a prime implicant, it should be a largest group possible, not the smaller groups in the largest groups. Okay. A prime implicant is a group of minterms that cannot be combined with any other minterms or groups. And it is a cube that is not completely covered by another implicant representing a larger cube. This is the meaning. Okay. We should not make a smaller groups within a larger group. Next, essential prime implicants. Essential prime implicant is a prime implicant in which one or more terms are unique. And how we are considering the unique term is the minterm should not be combined in any other way. If you are considering a K-map, okay, if you are considering a K-map, let us consider a 3-variable K-map. Okay, I am having logic highs for these 4, and I am having a minterm 1 here. Now, when we group these 4 and this one with these leftmost and rightmost cells, okay, and here when I'm considering this minterm 0, 1, 4, 5, this minterms 1, 4, 5 is not combined in any other way. It is combined in only one way. So it is a essential prime implicant. Okay, it is a essential prime implicant. And this minterm 2 is combined with minterm 0. This minterm 2 is combined in only one way. It cannot be combined in any other way. So, which is a unique term. So, this is also an essential prime implicant. When we are calling a prime implicant as essential, whenever the prime implicant consists of at least one unique term in it. Okay, unique minterm in it. And it should not be combined in any other prime implicant. And this is the procedure that we have to follow while finding the essential prime implicant. Find the prime implicants by finding all permitted maximum sized group of minterms. Find essential prime implicants by identifying those prime implicants that contain at least one minterm not found in any other prime implicants. First, we have to write all the possible group of minterms, maximum sized group of minterms. After getting all prime implicants, we have to check for the unique minterms which are not combined in any other way. And that prime implicants we can call it as essential prime implicants. Now we will see one example how to write an implicant of a function, prime implicant and essential prime implicant. In exams, they may ask you to write the implicants, prime implicants and essential prime implicants of a function. That time you have to write all the implicants, okay, with a single minterm, minterms by grouping 2 cells, 4 cells, 8 cells, like that. Okay. Implicants of a function with a single minterm. Okay, these are the each minterm in a function is a implicant. Okay, each minterm which is written in the form of variables, binary variables. Okay, this we are calling it as an implicant with a single minterm. Next, implicants of a function by grouping two ones. First, we have to go for single midterm. Those are implicants of the single midterm. Next, we have to group by grouping two ones. Here for this example, okay, we will get six groups possible with two ones. Okay, we can make six groups. Okay, each group is a pair. Two cells are grouped, which we are calling it as a pair. 0, 2, 0, 4, 4, 5, 5, 7, 7, 3, 3, 2, and 2, 0. Total six implicants we are having by grouping two cells. Okay, this is the implicants of a function by grouping two ones. And now we don't have a grouping of four ones here. No four cells are adjacent to each other. So we are not having a function with four cells. Okay, so the implicants of this function for single minterm and grouping two ones. Next, prime implicants of the function. We have studied how to write the implicant of a function, and now we will study how to write a prime implicant for this function. Prime implicant is nothing but the largest group possible. Okay, largest possible group by grouping more number of ones. Here, this the same example, we can make six groups. Okay, six groups we can make by grouping two ones. Okay, we have to consider all the groups possible. Okay, all the combinations possible, and we have to consider. We can consider the terms which are already grouped also for grouping a largest group possible. We can group this 0 with 4 and then 2. Okay, and we can group this 3 with 7 and also 2. And also with 2. We can group this 4 with 1 also, 5 also. We can group this 5 with 7. Okay, like this we will get 1, 1, 2, 3, 4, 5, 6. Okay, 6 groups possible by considering grouping of two ones. Next, essential prime implicant. Consider the example G is equal to f of a comma b comma c, that is equal to summation 2, 3, 4, 6. Here A is the MSB and BC are the LSB bits. First we have to write a 2 power 3 number of cells in the K-map, that is equal to 8 cells. And after that we have to enter a decimal notation for each of the minterms. And after writing the decimal notation, we have to enter a logic highs for this 2, 3, 4, and 6. And next we have to find out the prime implicants. Okay, prime implicants of a function. Now, here we are having logic highs for the minterm 2, 3, 6, and 4. First, what we have to do, we have to check for the larger groups possible. Can we group it as 8? No, because no 8 cells are adjacent to each other. Next, go for 4. Can we make it as a quad? No, it is not possible. Next, go for pair. Okay, now we can make it as a pair. We can make this 2, 3 cells which are adjacent to each other, and we can make it as a pair, and we get the product term A bar. From these two terms, we will get B. Okay, A bar B. And when we group this 4 with 6, midterm 4 with 6, this leftmost cell and This is rightmost cell. Both are adjacent, okay, which are logically adjacent because only one variable is changing here. So the midterm 4 is adjacent to 6. So we can group these two, and the simplified expression that term is from this row we are getting A, okay, and from these two rows we are getting here 0 0 is there, here 1 0 is there. So we are eliminating the variable B and we are having the variable C bar. Okay, now the simplified expression is AC bar. We are eliminating this and we are considering the C bar. Now we will get AC bar, AC bar. Okay, after grouping the 4 and 6, another group is possible by considering the main terms 2 and 6. How to write a prime implicant? We have to make all the larger groups possible. Okay, so we are considering this 2 and 6 midterms to group. Okay, we will get BC bar as a product term. Here, this midterm 4 is unique for the group 4 and 6 because it is combined in only one way. Midterm 3 is unique, which is combined in only one way. But midterm 2 and 6 are combined in two ways. So the unique midterms product term we have to consider in the final expression. We have to consider A bar B, where 3 is unique, where 3 is unique, and we have to consider this BC bar. We have to consider this 4 6, that is AC bar, which is unique. Okay, and where midterm 4 is unique. Okay, in this way we have to find out the essential prime implicant of a function. These are the MCQs. Please go through the PPT and answer the questions. And total 10 MCQs are there. Please try to solve this. If you are not able to find the answer, please check the MCQs document. Okay. Next assignment. Please try to solve these problems. Okay. And then in this session, we have studied about the Karnaugh maps. The Karnaugh maps are developed as a means of eliminating input variable redundancies in a Boolean equation. And the maps of 3 variables are illustrated. We have solved some problems on this 3 variable key map. And we have studied about the implicants, prime implicants, and essential prime implicants. Implicant of an output function is any single midterm or permitted group of midterms. Prime implicant is a maximally sized group of midterms or max terms. And essential prime implicant is a prime implicant that contains unique midterms. At least one unique midterm should be there in the group. Then that group or that product term we are considering as a essential prime implicant. Thank you for listening to this session.